So the random variable x has a probability function. So we can see here the probability function. How do we read this? Well, this basically is saying that the probability of x equaling to 1 or 3 is represented by k times whatever that outcome is. If it's 1, it will be k times 1. If it's 3, the probability will be k times 3. And then also that the probability is equal to k times x minus 1 when the outcomes are 2 and 4. Now we can take this probability function and we can actually represent it on a table. And it's quite nice to represent it on a table because then you can see all the outcomes. So I'm going to list all my outcomes. So x can be 1, it can be 2, it can be 3 and 4. I got those outcomes from there. Okay. And what is the probability associated with each? I'll write that down. Probability of x equaling to x. Well, when x is equal to 1, it follows this one. It will be k times x, which is 1. When x is equal to 2, it follows this one, which is k times x minus 1. X is 2. When x is equal to 3, it's up here. That follows kx, so that's going to be k times 3. And when x is equal to 4, it follows this. So that is k times x, which is 4 minus 1. And we can then go and write down what each of those probabilities are. So I've written all my probabilities, shown all the outcomes. So here's a sample space essentially. So what are the probabilities associated with each? Well, I've got k here. And then I've got, again, k here, 3k here, and 3k here. Part A says find out the value of k. We know that all probabilities in this sample space, since I've got all the outcomes, should add up to 1. So if I add everything up, k plus 3k, so adding all of these probabilities up, plus 3k, it should equal to 1. So then I've got 8k is equal to 1, therefore k is equal to an eighth. Then it goes on to say find the probability that x is greater than 1. Well, let's understand what it's asking here. X is greater than 1 means we're looking for when x value is greater than 1, i.e. it could be 2, 3 or 4. So 2, 3 or 4 is representing this. So we're looking for the probability of all of those. So k, add 3k, which is 7k. So part B, probability of x being greater than 1 is equal to 7 lots of k, but we already know what k is, so it's 7 lots of 1/8, 7/8. Okay.